We're here at the National Air and Space Museum, here in our Space Hall, and we're standing in front of Skylab, which was the first American space station, launched in May of 1973. And I'm here with Dr. Carolyn Huntoon, who is a scientist who worked on the effects of weightlessness on human beings, especially in Skylab. So welcome, Carolyn.
Oh, it's a pleasure.
It's very nice to have you here. Now, I understand that your study of human beings and weightlessness began very early. Can you tell me about that work?
Well, yeah. Actually, I was in graduate school at Baylor College of Medicine in Houston and had the opportunity to work with my major professor on some studies he was doing with the Mercury and Gemini astronauts at that time.
Mm-hmm.
So it was a lot of fun to, I didn't get to know the astronauts, but I certainly became familiar with their blood and urine samples.
What were you looking for?
Well, at that time, it was a complete unknown as to what happened to humans in weightlessness.
Mm-hmm.
So we started with just sort of what you would call routine clinical measurements. Then we started looking at some of the endocrinology that would react to stresses of spaceflight. The issue, of course, with all the astronauts was, is everything going to be okay when they come home? You know, are they going to be fine, they're going to be healthy or what have you? Because there were a lot of hypotheses that people going into weightlessness were going to have all these terrible things happen to them.
Mm-hmm.
So we showed right away that that did not happen. And then we were saying, well, what was occurring, you know, and all. So by collecting blood and urine samples and before and after the flight, we were able to measure various compounds in the urine, hormonal compounds, as well as the electrolytes and things like that, and found some interesting and some significant changes.
Mm-hmm. Such as?
Well, the big program that we did, and I worked with him the most on, was the Gemini 7, which was a 14-day mission with Borman and Lovell, and those guys were real heroes because they measured everything they ate was a special diet on a cycle, and we collected all the urine before the flight, during the flight, and after the flight, and they have some stories to tell about doing all that.
I'm sure that took a lot of discipline.
If you've seen a Gemini capsule, you know it was a small place.
Yes.
But 14 days was important because that's how long it would take to go to the moon and back. And
Yes.
they figured if these guys were healthy in 14 days, then we don't have to worry about the health of the Apollo astronauts.
Okay.
So when we got all those samples back and analyzed them, we found that there was indeed a change in metabolism in spaceflight. Calcium was lost in spaceflight. And we found out before and after the mission that red blood cells were changed, and that upon recovery after a mission, the astronauts were in a less hydrated state and had lost a lot of fluid and electrolytes.
So how did that affect what was planned for the Apollo mission, and were there similar scientific studies on the Apollo mission?
Apollo, as you know, was to go to the moon and come back and do scientific studies on the lunar surface. There were no medical experiments approved on Apollo. But on the lunar surface, the physicians had the EKG monitors on the astronauts in their suits, spacesuits. And there were some cardiac arrhythmias, and this got everyone's attention real fast.
I imagine. Did that turn out to be a big deal?
It was not a big deal when we got back. The crews were fine. They never had them again. And the doctors decided it was because they were overworked and had not had adequate intake of fluid and electrolytes.
Okay.
So they managed that way. But that was our big Apollo scare. But that also fed into the experiments that I was getting ready for Skylab because they were fluid and electrolyte oriented with the endocrine control system. So that was my opportunity to get everyone more interested in how I wanted to study this in the first place.
I was very interested to ask you about the work that you did on Skylab, because my understanding is in those longer duration missions where you might see more effects on the human beings for a longer exposure to weightlessness, you were actually leading some of the science that was being done.
I did, and we had a terrific opportunity there because it was everything from exercise capability, vestibular, red blood cells, sleep, everything. And calcium was a big issue.
Okay.
And we did all that work, and what made it so special, it was long duration, as you mentioned. There were 3 missions in 28 days, 56 days, and 84 days, I believe. 3 crew members on each mission.
Yes.
And we did the exact same experiment on all 3 of them. It happened, what was nice about all of that was that we had a good baseline before the flight. We got these samples back from flight which showed what happened in weightlessness. Then we had a long period post-flight that we were able to make the same measurements to see when they returned to normal.
And what did you learn? What do you feel like was really learned in terms of the science of the human body?
Well,
from
I think
Skylab?
one thing is that the human body is very agreeable to weightlessness. There were changes that were very interesting, and we documented them. And we plan then to proceed with understanding those changes, why they happened.
Okay.
We had a decrease in red cell mass. We had a decrease in calcium balance, even though they were eating a good calcium diet. The bones kept losing calcium. We had a decrease in muscle mass, although they were exercising almost every other day a lot. Their hearts were not working as effectively up there. They didn't have to pump as much because they weren't pumping against gravity.
Yes.
So their hearts became kind of sluggish. That was of interest and something to study for future missions.
Now, that was really groundbreaking research that allowed then the shuttle program and the International Space Station and those longer missions to really
Yes,
come to fruition.
that's
Can you
right.
talk a little bit about why it's important to continue to study the human body and weightlessness?
Well, yes. As I mentioned, we did observational experiments, if you will, on the Skylab, and we measured a lot of changes. And then you say, well, are these important? You know, and the doctors go, well, what does that tell me? You know, kind of thing. So what you need to do is start dissecting those changes and make more precise measurements. Look at the specific enzymes that change and the time changes and that sort of thing. And those are the experiments that are underway right now on the space station.
Very interesting. Carolyn, this was really a pleasure. Thank you very much for coming.
You're welcome.